Let me introduce the topic for this project. Week 12 Capstone Project, Customer Churn Prediction. This week, we will work on a real end-to-end data mining project. We will predict customer churn using the telecom customer churn dataset. Churn prediction helps companies know which customers might leave. Let us start our journey step by step. Running the cell now. What other problems can you solve with churn prediction? Try naming a few. Let us keep our notebook clean by hiding warning messages. We are going to suppress warnings so the output is easy to read. Here we import the warnings library. Import numpy as np. We set the random seed to 42 for reproducibility. This line tells Python to ignore all warnings. Running the cell now. This code sets up a clean and reproducible environment by suppressing warnings and fixing the random seed. While you don't see any output, this step is crucial to ensure that our project results are consistent and free from distracting warning messages. It lays the foundation for a smooth and reliable analysis as we begin our customer churn prediction journey. Let us load our customer churn data from a public source. Now we are setting up the data for this project. We import pandas, a popular library for data handling. We specify the URL for the telecom customer churn dataset, provided by IBM. We load the dataset into a pandas data frame. We print out its dimensions, which tells us the number of rows and columns. Let us view the first 3 rows as a preview. Running the cell now. This output shows the initial exploration of the telecom customer churn dataset, confirming it has 7,043 rows and 21 columns, representing customer records and their attributes. The first 3 rows display a mix of numerical and categorical features, including demographics, service details, and the target variables are churn, which we will predict. This step ensures we understand the dataset structure before proceeding with analysis and modeling. Can you find a column in the preview that looks interesting? Write it down. Data understanding is an important first step. Step 1. Data understanding. Before we work with the data, let us check what each column means. We want to look for the target variable and useful features. Some columns may need cleaning or fixing. Running the cell now. What do you think the target or label should be in this dataset? Let us inspect column types and see if there are missing values. We are going to see the names of all columns and check what type of data each holds. This also helps us look for missing or unusual values. Running the cell now. The output shows our dataset has 7,043 rows and 21 columns, with no missing values in any column, which is ideal for analysis. Notice that most columns are of object type, but key numeric features like tenure and monthly charges are numeric, while total charges is still an object, indicating it may need cleaning before use. This overview helps us identify the target variable's churn and highlights which features might require data type conversion or further inspection. If you spot any columns with unusual types, make a note. Now, let us prepare our data and fix problems. Step 2. Data cleaning and pre-processing. The data may have missing values or types that need changing. Pre-processing includes fixing any issues and preparing the data for analysis. Running the cell now. What are some common data problems you have seen so far? Let us check for missing data in every column. We examine every column to see how many missing values are in each. This helps us plan how to handle missing values. Running the cell now. Here, the output shows the count of missing values in each column of our dataset, with all zeros indicating no missing data. This confirms that our dataset is complete and ready for the next steps, ensuring that we won't need to handle missing values during pre-processing. This check is crucial for data cleaning to avoid errors in later analyses. Sometimes, numeric columns are read as object type. Let us fix that. Here we convert total charges to numbers. If the value cannot be converted, it becomes missing. This helps us handle the total charges correctly. Running the cell now. Here, the code converts the total charges column to a numeric type, coercing any invalid entries to NaN. The output shows there are 11 such missing values, indicating data that needs to be addressed before analysis. This step highlights the importance of detecting and handling inconsistencies during pre-processing. Why might a column with numbers be stored as a string? Think of at least one reason. We fill in missing numbers with the column average so we do not lose rows. We find the average value for total charges. Then we fill empty values in total charges with this average. This ensures our data will not break any later steps. Running the cell now. Here, we filled the missing values in the total charges column with the column's mean, ensuring no gaps remain in this key numeric feature. This step is crucial in pre-processing because it prevents errors in later analysis and modeling, while maintaining the overall distribution of the data. Notice how this simple imputation prepares the dataset for more accurate and reliable insights. Try renaming another column to practice using pandas. Identifiers are not useful for prediction. Let us drop customer ID. Unique identifiers like customer ID do not help predictions. Removing this column makes our data smaller and cleaner. Running the cell now. The code drops the customer ID column, which does not provide predictive value, helping to simplify the data set. This step is key in data cleaning by removing irrelevant features, ensuring the data is more manageable and focused for modeling. Since there's no output shown, the takeaway is understanding why and when to remove such columns during pre-processing. For modeling, our target should be numbers, not words. To train models, it is better if our labels are numbers. This line converts yes to 1 and no to 0 in the churn column. Running the cell now. Here, we've transformed the churn column from categorical text values into binary numeric values, mapping yes to 1 and no to 0. This conversion is crucial for enabling mathematical operations and model training downstream, ensuring the data is in a consistent, machine-readable format. Although no output is shown, this step sets the stage for efficient analysis and predictive modeling. What other columns could be converted from text to numbers? Understanding patterns makes predictions easier. Step 3. Exploratory data analysis. We need to explore and visualize our data. This helps us spot patterns, outliers, and trends. Let us look for relationships between features and churn. Running the cell now. Suggest one thing you would like to visualize in this data. Let us see how many customers left versus stayed. We are going to plot the churn rates of customers. First, we import the matplotlib.pyplot library for plotting. We create a bar chart to show the counts of customers who stayed versus those who churned. We set the title of the plot as churn counts to describe what the chart shows. We label the x-axis ticks as stayed and churn for clarity. We add a label to the y-axis to indicate it represents the number of customers. Finally, we display the plot on the screen. Running the cell now. This bar chart shows the distribution of customers who stayed versus those who churned, highlighting a clear count difference between the two groups. Notice how the taller bar for stayed indicates most customers remain, while the smaller churned bar reveals fewer customers leave. This visualization helps us understand the baseline churn rate before diving deeper into patterns affecting customer retention. Try plotting another column against churn for practice. Let us explore if churn is different for men and women. This line adds a comment explaining that we are comparing churn rates by gender. Here, we group the data frame by gender and calculate the average churn rate, then plot it as a bar chart with specified colors. This sets the title of the plot to the churn rate by gender. This labels the y-axis of the plot as the churn rate. Finally, we display the plot to visualize the churn rates by gender. Running the cell now. This bar chart shows the average churn rate for each gender, revealing that one gender may have a higher tendency to churn than the other. By grouping the data and calculating mean churn, the code helps us identify potential demographic patterns, which is crucial for targeting interventions in customer retention. Notice how the clear difference in bar heights highlights gender as a key factor to consider in our analysis. Let us check if people with higher bills are more likely to churn. This comment explains that we are examining the relationship between monthly charges and churn using numerical trends. We import the Seaborn library for creating statistical visualizations. We create a box plot to compare monthly charges between customers who churned and those who stayed. We add a title to the plot for better understanding of what the box plot represents. We replace the x-axis tick labels with more descriptive names, stayed and churned. We display the plot to visualize the data. Running the cell now. The box plot compares the distribution of monthly charges for customers who stayed versus those who churned. Notice that customers who churn tend to have higher median monthly charges, highlighting a potential link between cost and churn. This insight helps us focus on pricing as a key factor in customer retention during our exploratory analysis. Try writing down any pattern you see in the box plot. We encode text columns so models can use them. Step for feature engineering. Some columns are not numbers yet. Let us turn categorical features, like gender, into numbers for modeling. Running the cell now. List 2 more text columns that may need encoding. Models only understand numbers, not words. Let us use one-hot encoding. We look for all columns that have text values. Then we use one-hot encoding to turn each category into its own column with a 1 or 0. This lets the model use each possible value. We print how many columns we have after encoding. Running the cell now. The output shows that after applying one-hot encoding, the dataset now has 46 columns, reflecting the transformation of categorical features into multiple binary columns. This increase in columns is expected, as each unique category in columns like gender is converted into a separate numerical feature, making the data ready for modeling. Notice how this step expands the dataset while preserving all categorical information in a machine-readable format. Let us separate our features from our labels. We start by separating our dataset into the input features and the output labels. Create X by removing the churn column from the data frame, so it contains only features. Create Y by selecting the churn column, which is the label we want to predict. Running the cell now. Here, we've separated the dataset into features X and labels Y, preparing for modeling. Notice that the churn is removed from X since it's the target variable we want to predict. This step is essential before converting categorical features, like gender, into numeric values for analysis. What other columns might you try using as a label in a different project? To test accuracy, we split data into training and testing parts. To check if our model will work on new data, we split our data. 80% will be for training, and 20% for testing. We use a random seed so you can get the same split each time. Running the cell now. Here, we use train_test_split to divide our data into training and testing sets, with 20% reserved for testing. This step ensures that our model learns from one portion of the data and is fairly evaluated on unseen data, which is critical before we proceed with feature engineering and modeling. Notice there's no output here because the function simply prepares the datasets for the next steps. Let us see if we can predict who will leave using a basic model. Step 5. Predicting churn with logistic regression. We will use a simple but powerful model called logistic regression. This model is good for prediction when there are two possible choices. Let us train and test our first model. Running the cell now. Try explaining what binary prediction is to a friend. Let us train the model and make predictions. We start by indicating that we will fit a logistic regression model. We import the Logistic Regression class from the Churn library. We create a Logistic Regression model object with a maximum of 500 iterations. We train the model using the training data features and labels. We use the trained model to predict labels for the test data. Running the cell now. This code fits a logistic regression model to our training data and uses it to predict churn on the test set. Although there's no textual output here, the key point is that the model is now trained and ready to generate predictions, which we will evaluate in the next steps to understand its accuracy and effectiveness in classifying customers as churned or not. What does max_iter do in this model? Look it up if you are curious. How well did the model do? Let us check with accuracy score. This line is a comment indicating that the following code checks the accuracy of the model. We import the accuracy_score function from Churn.metrics to calculate how accurate the predictions are. We calculate the accuracy by comparing the predicted values with the actual test labels. We print the accuracy rounded to 3 decimal places to display the model's performance on the test set. Running the cell now. The output shows a test accuracy of 0.822, meaning our logistic regression model correctly predicted customer churn about 82% of the time. This high accuracy suggests the model is effective at distinguishing between customers who stay and those who leave, which is the goal of this step in building a binary classifier. Try building a logistic regression with a different random_state value. Trying more models helps us compare accuracy and pick the best one. Step 6. Try another model, random forest. Random forests use many decision trees and vote for the best answer. They handle mixed data types well and often improve accuracy. Let us see if this model is better. Running the cell now. If you have time, experiment with changing the number of trees in the model. Let us see how well the random forest model can predict churn. We start by describing that we will train a random forest classifier and check its accuracy. We import the random forest classifier class from scikit-learn's ensemble module. We create a random forest model with 100 trees and a fixed random seed for reproducibility. We train the random forest model using the training data. We use the trained model to make predictions on the test data. We calculate the accuracy of the model's predictions compared to the true test labels. We print out the accuracy score rounded to 3 decimal places. Running the cell now. The output shows the random forest model achieved an accuracy of about 79.5%, which you can compare to previous models to see if it performs better. This indicates the model's voting approach across multiple trees is effectively capturing patterns in the data. Notice how this aligns with the lesson goal of testing if random forest improves prediction accuracy. Which model was better? Can you think of why? Let us find out which features were most important in the random forest model. This section will display the top 5 features based on their importance in the model. We import the NumPy library for numerical operations. We get the indices of features sorted by their importance scores in descending order. We retrieve the feature names from the dataset columns. We loop over the top 5 features to display their names and importance scores. For each of the top 5 features, print the feature name and its rounded importance value. Running the cell now. Here, we see the top 5 features that the random forest model found most important for predicting churn. Notice that continuous variables like total charges, tenure, and monthly charges have the highest importance scores, indicating they strongly influence the model's decisions. This insight helps us understand which customer attributes drive predictions, demonstrating how random forests can highlight key factors in mixed data. Practice, ask yourself which features you would have guessed as important before seeing this output. Great job making it through an entire project pipeline. Step 7, Wrap up and next steps. You just finished a full churn prediction project, end-to-end. Try experimenting with other models or feature selections. See if changing settings improves results. Keep exploring, and notice how your skills have grown. Running the cell now. What else would you like to predict with this workflow? List 2 ideas. Thank you so much for staying with us till the end. Thanks for following along. Please subscribe to our channel and let us know in the comments what project you would like next. Happy coding and data mining. Running the cell now.